Good morning, class. We are looking at statistics practice test number 3, module 3, covering chapters 6 and 7. Here's chapter 7, estimating parameters and determining sample sizes. Chapter 7. Answer the following, true or false. The confidence interval estimate of the population mean is constructed around the sample mean. That's a correct answer. Here's the justification. Confidence interval has the formula x bar plus minus e for the population mean. For the population mean, x bar plus minus e, where sigma of x bar is sigma over square root of n, and e is z alpha over 2 sigma over square root of n. This is called the margin of error. Estimation means assigning values to a population parameter based on the value of a sample statistic. Generally speaking, we are interested in the population parameter. We don't have access to it. We have to live with what we have, which is a sample statistic. The confidence level is denoted by 1 minus alpha, 100%. The maximum error, also known as the margin of error, of the estimate for mu based on known sigma is what we wrote here. E is z alpha over 2 sigma over square root of n. The parameters of t distribution is r, and that's only 1 degrees of freedom. If you remember, for binomial distribution is n and p. For normal distribution is mu and sigma. So reminding you that for binomial distribution is n and p. For normal distribution is mu and sigma. For t distribution is only 1 degrees of freedom. What criteria are required to apply the t distribution to make a confidence interval for mu? Number 1, the sample must be a simple random sample. Number 2, either the sample is from a normally distributed population or n is large. How large is large? Larger than or equal to 30. Population standard deviation, sigma, is unknown. Here's the third one, and that's almost always the case because we don't have access to the population. That's why most of the time, instead of normal distribution, we use the t distribution. Could somebody read this for us? I appreciate it if anybody wants to read this for us.
Sample statistics is used as a point estimate, which is a specific numerical value, estimate of a parameter. A point estimate is a single value or point used to approximate a population parameter. Example, the sample proportion p hat is the best point estimate of the population portion p. Confidence interval, we can use a point estimate to construct a confidence interval estimate of the true value of a population parameter.
Perfect. Excellent. So what is the point? The point is we start from somewhere. known as the point estimate. What is a point estimate? Sample statistic. And then we make up an interval known as a confidence interval. So we're starting with point estimate. For example, for P, we start with P hat. For mu, we start with X bar, and then we expand it into some sort of an interval. And that is a confidence interval where we are 90%, 95%, 99% that it contains the true population parameter. Find the value for T, for a T distribution with a sample size of 20 and a confidence level of 95%. Well, here's the graph. "95% confidence interval" means smack in the middle is 95% or 0.95. Remember, the total area under the curve is 1 or 100%. So when we want to make up a confidence interval, we put it in the middle. So the total area in the two tails is 5%. So what is this? 5% divided by 2, which makes it which makes it 2.5% or 0.025. This area is 0.25, so is this one. So 5% divided by 2. That's how you set up your confidence interval if you were to do the drawing. Degrees of freedom in this case is n-1. So we need the T distribution table, everybody. And again, I'm going to show you both the table and of course you can use technology. So the table looks something like that. On the left column, we have degrees of freedom. And you notice I stopped at 5 and used 18 because of the limitation of the page. And at the top, what do you see here? Area in one tail corresponding to area in two tails. So for example, when we have a 95% confidence interval, the area in two tails is 5%, okay? So the area in two tail would be 5% or 0.5. In one tail would be 0.025 that I showed you. So this is what we are looking at, okay? So we need degrees of freedom. What is degrees of freedom? Degrees of freedom, everybody, is n-1, 20 minus 1 or 19. So we look for number 19 in this column, everybody. 95% confidence level means the total area in the two tails is 5%. So area in two tails is 5% or 0.05, or in one tail is 0.025. That's why I wrote those. Now, when you put these two together, the result is this number. So this one is positive 2.093. This is the same thing, but negative. So there are two answers, plus, minus 2.093. So find the values for T, for a T distribution with a sample size of 20 and confidence level of 95%. Again, you graph, look at the two tails. This is how you use technology. Find the values for T, for a T distribution with a sample size of 30 and a confidence level of 90%. So if now this changes to 90%, everybody, the two tails are what? 10% or 0.1. So it is important to know that this corresponds to 10% area. In two tails. Or better yet, let's clean up everything and redo this in this manner. So if this is 90%, everybody, then alpha over 2 is 10% divided by 2, or 5%, or 0.05. This is also 0.05. So degrees of freedom, n minus 1, 30 minus 1, or 29. So you look for 29 here. Area in one tail is 0.05, in two tails is 0.1. So this is what you're looking for, everybody, right? Area in one tail, 0.05, in two tails, 0.1. Put them together. Here's the answer. So plus, minus, because this is positive 1.699. This is the same thing, but negative. So negative 1.699 here, and this is positive. And we're done as far as using the table is concerned. But let's discuss other methodologies. Okay. So here's a TI calculator. So we want to find the T distribution. We want to find the T-score. Second variables, inverse T. We put two entries, the left area and degrees of freedom. So area to the left is 0.05. I'm going to do one of them. I'm going to do this last part. So this area is 0.05. The area in the left side is 0.05. Degrees of freedom, 30 minus 1, or 29. And of course, the answer you get is one of them, everybody, right? Because this gives you precisely this one. And of course, with 3 decimals, they're identical. Of course, this gives us more decimals. And you should recognize this one is therefore positive, okay? You want to be very careful with that. Needless to say, if I make this 0.95, it gives me the same value, but positive, this one. Now, of course, you can use T distribution calculator in Star Trek or Google Calculator or in Excel. I'm showing you various ways to do this, everybody, okay? With technology. And it is something you can find in MOM or under the last module in Canvas. I have some information about TI calculator and other calculators. Find the critical chi-square value for 20 degrees of freedom when the area to the left is 0.01. By the way, we need degrees of freedom. It's given in this case. It's a chi-square, okay? And if n is given, as it is the case in the next one, you have to subtract one. But when degrees of freedom is given, you got to be very careful with that. So let's see what's going on. Could somebody read this, please?
Is it the chi-square
Yeah,
distribution?
chi-square. Yeah, thank you.
Chi-square distribution must be used to calculate confidence intervals for variances and standard deviations. Oh, I already forgot what it's called.
The chi-square.
The chi-square variable
Good.
is similar to the T variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol for
Chi-square is chi-squared, a Greek letter, pronounced chi.
All right. A chi-square variable cannot be negative, and the distributions are skewed to the right.
Excellent, excellent. So here's the table that you find in a Canvas module towards the end where we have the tables. And here's the way it looks like. It goes from 0 to infinity. The total area under the curve is 1. And the shaded area is equal to chi-squared or chi-squared of alpha, they call it, okay? Because completely is on one side, as you can see here. And we need degrees of freedom and area to the right. So what is degrees of freedom here? It's given as 20, and area to the left is 0.01. This is what's given left, everybody, okay? So area to the left is 0.01. But we need degrees of freedom and area to the right. So this is fine. This is not a problem. But if the area to the left is given as 0.01, the area to the right must be 1 minus that, because remember, the total area under any curve that we discuss in statistics represents the total probability and therefore equals to 1. So 1 minus that is 0.99. So we need degrees of freedom of 20. On the left column, you find the degrees of freedom. I didn't have enough room. So when we go down to number 20, this is what we need. And this is what we need as this represents alpha area to the right, everybody. Putting them together, that's the answer. The way we write it, we can just write chi-squared is equal to that. Or we can write chi-squared of left side being 0.01, right side being 0.99 is 8.260. Okay, so this is like here, class, okay? Because area to the left is 0.01. So if I were to graph this as an example, it will look like this. Where this area is 0.01. And area to the right is 1 minus that. The reason we use area to the right because of the way we read the chi-square table. And so now find the critical chi-square value when n is 30. So we're going to go down here and find number 30 minus 1 because you need degrees of freedom. And the area to the right is 0.9. Remember, we need area to the right. So this one is actually looks pretty good. So the area to the right is 0.9. This doesn't look good either. So if I were to graph this, as far as the graph would be something like that. Okay, I didn't do a good job on this one. This is 0.9. So degrees of freedom is 30 minus 1 or 29. Area to the right is 0.9. So on the left column, look for number 29. We go down to find number 29. And up here, we look for 0.9. Put the two together and gives us the answer we are looking for. So chi-squared of the right is 0.9, okay? Or just chi-squared of 0.9 is 19.768. You can always use a technology class, and you can even look up chi-square critical value calculator. A statistician is interested in estimating at a 95% confidence level the mean number of houses sold per month by all real estate agents in a large city. It is known that the population standard deviation is 1.9. How large a sample should be taken so that the estimate is within 0.65 of the population mean? So the very first thing is, what is given? 95% confidence level. So, or 95% confidence interval. This is population standard deviation. Sigma is 1.9. We want to know how large a sample should be if the estimate should be within 0.65. This is E equals 0.65, everybody. So E is equal to 0.65. Now, there are a few formulas I want to remind you of. Confidence interval has the formula X bar plus minus E for the mean. So if you want to find the confidence interval for the mean, that's what you do. Sigma of X bar is sigma over square root of n. So what is E? When you're dealing with sigma known, E is Z alpha over 2 sigma over square root of n. So we use X bar plus minus E. Now, what is this asking? How large a sample should be taken so that the estimate is within 0.65? So it's given us the E. They want N. And how do we go from here to here? I hope you realize if you square both sides, I'll quickly show you. And it's very straightforward. If you square both sides, get E squared equals Z squared or Z alpha over 2 squared, sigma squared over N. And I hope you know that you can do the cross product. So you can take the N there and bring E down here. So I hope you see if you bring the E down here, becomes Z squared, sigma squared over E squared, which is this formula. So square both sides and solve for N. Now, 95% confidence interval. We need to find the Z score. It's one of those common ones where the score is plus minus 1.96. So when we have a 95% confidence level, that means smacked in between is this area in the middle is 95%, everybody. Then the total tails are 5%, each one 5% divided by 2 or 0.025. This number is positive 1.96, this one is negative 1.96. So we use, it doesn't matter which one you use because you're going to square it, okay? So what we use 1.96, we put it into this formula where Z is known, sigma is known, and E is known. So we use this formula, plug in. So the only thing we had to look up from the table or technology was the value of Z. Everything is given, you put it in. Now, I want to show you what you get with some decimals. And you want to be very careful with this number. It's better to pick it up from technology and carry a couple of decimals. However, because we are asking what's N, and N must be a discrete value, you must always round up. Let me explain that to you why. Even if it's 32.1, the answer is 33. Why is that? Because it says minimum we need this number, 32.82. That means if I go with 32, it's not going to work. So if I need minimum of 32.1 and I go with 32, it won't work. So if you have to round up. By the way, if n equals 33 works, that means any other number larger than that will work. Okay, this is the minimum number. Find this 95% confidence interval if the mean for such sample size is 3.4. Now we're going to go to this formula, everybody. X bar plus minus E, where X bar is given as 3.4 and E, we had it from here. So plug in. So mu is between X bar minus E and X bar plus E. So mu is between 2.75 and 4.05. So I want to make sure we understand the concept. So through the calculation, we find mu being between two numbers. Because remember, we don't have access to the population mean. So we estimate it to be between these two values. And we are 95% confident that the true population mean is somewhere between these two numbers. That's the concept of a confidence interval. That's why you want it to be pretty high, 90%, 95%, 99%. Okay. The smaller this interval, the better the approximation. The higher the confidence interval, the better the approximation. The higher the value of n, the better the approximation. Could somebody read this question, please?
A random sample of 20 female members of a health club showed that they spend, on average, 4.5 hours per week doing physical exercise with a standard deviation of 0.75 hours. Assume the time spent on exercise for all female members is approximately normally distributed. What is the value of the point estimate of the population mean?
Excellent. First and foremost, let's see what's given. We are assuming normal distribution. N is 20. Now, for those 20 members, with the 20 members, the average is 4.5. That means X bar. I can't emphasize the importance of writing the proper notation. The proper notation, everybody. Per week, doing physical exercise with standard deviation of 0.7. So going back to those 20, n equals 20, standard deviation is 0.75. That's S. So n is 20, X bar is 4.5, S is 0.75. And I really can't emphasize this enough. This is extremely important to have it right. All right. As far as the point estimate of a population mean, the point estimate of mu, population mean is mu. This is mu, is always X bar. And therefore the answer is 4.5 hours. The population mean is approximated by the sample mean, which is known as a point estimate. So point estimate for mu is X bar. For P is P hat. Now we want to construct the 98% confidence interval for the mean time spent on physical exercise of all such females. Well, confidence interval, X bar plus minus E. S, instead of sigma of X bar, we're going to use S of X bar, which is S over square root of N. And E, which was Z alpha over 2, now is T alpha over 2, S over square root of N. So very similar to the formulas for the population, slightly different because we can't use the Z distribution, we must use the T-distribution, everybody. And that's the key. All right. So if we want 98% confidence interval, alpha is 0.02, meaning we have 98% here, everybody. And the tails are 2% divided by 2, 1%, or 0.01. So area in each tail is a 0.01. So N is 20. Degrees of freedom is N minus 1 or 19. And if we go with the table, we get plus minus 2.539, or you can use technology. We are going to calculate X bar plus minus E, which means mu is the meaning of this class. Mu is between X bar minus E and X bar plus E. We know X bar to be 4.5. What is E? The formula that we have here, T alpha over 2 S over square root of N. And we got the T, okay? We got the T, everybody. We have S, we have square root of, we have N, which is 20. So we can calculate the value of E. Again, we are doing it basically by hand. So 2.539, and it doesn't matter plus or minus because that's really the meaning of it here. Because we are, whatever this value is, we're going to subtract it from X bar, and then we're going to add it to X bar. So 2.539 times 0.75 over the square root of 20, putting it into a calculator with a bunch of decimals, results in 0.4258. So what is the confidence interval? X bar, which is 4.5, minus this, and X bar plus this. Mu is in between. Doing the math, mu is between 4.0742 and 4.9258. That means based on the information given here, we are 98% confident that the true population mean for the female members of this health club is somewhere between these two numbers, 4.0742 and 4.9258. The number of hours per week for physical exercise. If we were to do it by technology, for the confidence interval, you use stat test T interval and you enter X bar S confidence level. So we are going to put X bar is 4.5, S is 0.75, N is 20, and the confidence level is 98%. When we do the calculation, everybody, it gives us the number here. And as you can see, the number is pretty close. Again, the discrepancy is due to the fact that more decimals are used here. Okay, more decimals are used there. Out of 500 randomly selected adults, 300 said they were in favor of the death penalty for a person convicted of murder. What is the value of point estimate of the population proportion? And we are going to write the given. First and foremost, This is a binomial distribution because you're either for it or against it. You're either in favor or not. Two outcomes. Binomial distribution N 500, X 300. So that's the given information. The point estimate for P is P hat. We've discussed that before. And we know P hat to be X over N. Which makes it 300 over 500 or 3 over 5 or 0.6. Right, everybody? It's a simple calculation. 3 over 5 is an exact answer. So it's up to you what you want to write. That is the point estimate. All right. What is the 95% confidence interval for the population proportion? Well, we are going to look at some formulas, everybody, and we are going to use those formulas. Mu of P hat is P, confidence interval is P hat plus minus E. Sigma of P hat, square root of PQ over N. If P and Q are missing, we may have to use P hat Q hat over N, and E is Z, square root of P hat Q hat over N. When P is missing, we use that. Therefore, in this case, E is Z alpha over 2 square root of P hat Q hat over N. If P hat is 0.6, Q hat must be 1 minus that, everybody, 0.4. This is P hat. Q hat must be 1 minus that. So here's the graph, and we want 95%. So it's 95% here, 5% divided by 2 in each tail, total of 5% in two tails. And this happened to be one of those common ones, and we use the Z-score for proportion. And the reason we use a Z-score, remember, a binomial distribution, when we go to normal distribution, it's an approximation to binomial distribution. One approximation is bad enough. So in essence, we are using the normal approximation to binomial distribution when we do that. Okay, everybody? That's why we never go to T. So confidence level of 95%. So let's plug in. This value is 1.96. Doesn't matter, you get, say, plus or minus, because this will take care of that. Square root of P hat 0.6, Q hat 0.4 over N, which we wrote it here, 500. When you put it into a calculator, it gives you the answer, everybody. So we have 0.0429. So P hat, which is 0.6, plus minus E, that means 0.6 plus this number, 0.6 minus this number. So true P is in between. So P hat plus minus E. So subtract this from 0.6, put it on the left side, add it, put it on the right side, and put the P in between. By the way, sometimes they want it in this format, sometimes they want it in this format. You should be familiar with both and put the format that they ask you. So when we do the math, we end up with P being between 0.5571 and 0.6429. What does it mean? Based on the given information, our calculation indicates that we are 95% confident that the true population proportion P is between these two numbers. Let's discuss technology. So if we want to go with the TI calculators that test one proportion Z interval. And so we put in X is 300 here. That's why I can't emphasize the importance of the given. Okay. And so X and N confidence level was 95%. When you say calculate, it gives you the answer. And when you look at the answer and you compare it to what we got here to 4 decimals, this is the same. Up to 4 decimals, they are identical, everybody, which is pretty nice. All right. You can always use technology, but you have to justify your answer within reason. That's why I show formulas step by step. And then even if I use calculators, it's fine. But we are looking at formulas, steps, what's given, and everything else. Here's the last question. Anybody wants to read that for us? My apologies, it's not the last question. We have one more, but can somebody read this?
How,
How
ahead.
large a sample is needed to be 99% confident that the margin of error is 0.025 for percentage of golfers that are left-handed? If we assume that 15% of the golfers are left-handed based on a previous study.
Excellent. Again, we want to write what is given, everybody. We are going to write what is given. %99 confidence interval, margin of error E is a 0.025. E is 0.025. So that's the given. Assume that 15% of the golfers are left-handed. That is P hat equals 0.50. Now, let's discuss these formulas. We said confidence interval is P hat plus minus E. Sigma of P hat, we are going to use square root of P hat Q hat over N instead of PQ over N. E is Z alpha over 2 square root of P hat Q hat over N. If you look at this formula and you square both sides, you get E squared equals Z squared. By Z, I mean Z of alpha over 2. P hat Q hat over N. So all you have to do, take the N to the other side, bring the E squared here, and it becomes this equation. I hope you see that. If you solve for N, you get to this equation. So to find the N value, we use the E and solve for N in essence. Now, 99% confidence interval is also one of those common values that are used for confidence level. 90%, 95%, 99%. And we are dealing with a proportion, we go with the Z. So this is the graph So we have 99% here, which means 1% in the two tails, or 1% divided by 2 in each tail. So 0.01 divided by 2 becomes 0.005 in each tail. So this is a 0.005. Okay, that's how you get that. I want to make sure that we have the correct answer here. All right, so we are going to use this formula, and we need to find the z values from the table. Gives us plus minus 2.575. 2.575. So we have just about everything. When the confidence interval or confidence level is 0.99 or 99%, z ends up being these two numbers, and we use one of them, the positive one. Of course, we need, in this formula, we need q hat. Q hat is 1 minus p hat, 0.85. Q hat is 1 minus p hat, which makes it 0.85, everybody. We are ready to go. We got everything we needed. So let's write the formula and let's plug in. So z, we are going to plug in 2.575 and square it. P hat, we're going to plug in 0.15. Q hat, 0.85. E, 0.025. And please pay attention to 0.025. When you plug this into a calculator, and be careful when you do your math, this is what it gives you. And again, regardless of what this is, we have to round up because this is the minimum value we need. So if you go with 1,352, that's not good enough. So you round up always, regardless. Let's move on. Now, let's assume that we have no prior information suggesting a possible value for the sample proportion. In other words, if we go back to the previous question, they gave us p hat equals 0.15. Now they are saying we don't know that. Do your best. So when p hat is not given, you're going to assume p hat and q hat are both 0.5. Here's the reason. Because that's the most conservative estimate. The number that you will end up having must be larger than that, and it will be, because if you go with this formula, the product of p hat q hat is largest when the p hat and q hat are identical and they're both 0.5. That's why you assume that. Again, if you don't know it, you make this value, this product, the largest. And so when you do that, you see in some formulas, so p hat and q hat, this is the assumption. We have the same confidence level of 99%. We have the same E of 0.025. With that one, we have the same Z value of 2.575. Everything is the same except P hat and Q hat. Now, what I want you to notice is that the product of 0.5 and 0.5 is 0.25. Some books, they use the formula and they write 0.25 instead of P hat, Q hat, just like that. But the reason why, again, is because this is the product of P hat, Q hat. If you take it to be 0.5 times 0.5 becomes 0.25. Okay, that's why. Replace the Z, replace the E with the corresponding values. Do the math, plug it into a calculator, it gives you this number. So this has to go up. See, notice if I were to round this accordingly, I would get 2652. I must always round up to 2653. And that is extremely important. That's why when you do your work, make sure you pay attention to that. And if you show your work, even if you make a mistake, we can always work on partial credit. Given n equals 30, x bar equals 80.5, s is 4.6, assume normal population, find 98% confidence interval for population variance and standard deviation. Now, everything is given symbolically, so I don't have to write symbolically what's given. It's just everything is given. But what do we want? We want the confidence interval for what? Variance and standard deviation. By the way, normally we really don't care for variance, we want standard deviation, but the formula is that from the variance, we go to standard deviation by taking a root. The formulas are as follows. N minus 1 s squared over chi squared of the right less than sigma squared. N minus 1 s squared over chi squared of the left. This is for the variance class. This one, all you have to do, take a root. You just take a root. You don't have to go through the process of calculation again. Just take a root. That's all. Let's look at this. We have degrees of freedom, which is n minus 1 or 29. 98% confidence interval. This is known as 1 minus alpha. So these two are 2%, or each one is 1%. So degrees of freedom is 29, 30 minus 1. They're asking for 98% confidence interval. So this is 98%, and the two tails are 0.02. Each one is 0.01. So 0.98 in the middle, 0.01 for each tail. Now, we want to come up with this one, and we want to come up with this one, and we are going to use the table. Notice degrees of freedom is on the left, and on the left column, I didn't have enough room after 7, so I jumped to number 29. So we need to use number 29. For this one, area to the right is given as 0.01. So all I have to do, 29, and up here, find 0.01. When I put them together, that's the answer. 49.588, that's chi squared of the right. For chi squared of the left, for this one, area to the left is 0.01, everybody. So what is the area to the right? Is 1 minus that. The total area to the right of this one is 0.99. 0.991 minus this number. So now, again, degrees of freedom is the same thing as 29. Up here, I look for this number, 0.99, 0.99, which is here, everybody. And what do I find? 14.257, I put it here. So, into this formula, I have everything. I have n, so this formula. I have n minus 1. I can write 30 minus 1, or I just write 29. Either way is fine. S, 4.6 squared. Chi squared of the right. Chi squared of the right. 49.588. This one is the same as this one. Chi squared of the left. 14.257. The numerator is the same for both of them. The denominators are different. You plug this into a calculator, you get the following. Sigma squared is between these two values, which means we are 98% confident. The variance, the true population variance, is somewhere between 12.3748 and 43.0413. How do we get to the standard deviation? Just take a root, that's all. Take a root of this number, take a root of this number, and it becomes sigma. Using a calculator with a bunch of decimals, this is what we get, which means we are 98% confident based on the calculation and the information given here that the true population standard deviation, sigma, is between 3.5178 and 6.5606.